Good morning everybody. Now I am going to give a presentation on these contents and computer types, functional units, basic operational concepts and bus structure, performance, multiprocessor and multi-computers. And before going to these contents, and first of all we have to know that what is a computer. Computer is a fast electronic calculating machine that accepts digitized information. Only it accepts the binary information and process it according to a list of internally stored instructions and produces the resulting output information. So the list of instructions is called a computer program and the internal storage is called a computer memory. And we have different types of computers, and these computers are classified based on the parameters like speed of operation, cost, computational power and type of application. Depending upon these parameters we have different types of computers. So now first of all we discuss about desktop computer, and desktop computers are also called as personal computers, and the most common computer is a desktop computer which have processing and storage units, visual display and audio units and keyboards, and the storage media for this desktop computer is hard disk, CD-RAMs, and these personal computers are used in homes and offices. And what is the advantage of this personal computer is these personal computers are easily located on our desk, and it is very cost effective and easy to operate, and it is used in our normal general purpose educational and business applications. And next type of computer is notebook computer, and this is same as our desktop computer, only the difference is it is very portable and compact version of our personal computer. The next category of our computer is workstation, and workstations are having more computational power than our personal computer, but these are very cost compared to our personal computer. And these workstation computers are used to solve to our complex problems and which arises in our engineering applications. For example, these are used in our CAD and CAM applications. So next computer is nothing but it is enterprise system. It is also called as mainframe computer, and this is also having more computational power and a large storage capacity, and this enterprise system is used in business data processing in large organization. Commonly it is also referred as servers or supercomputers. Next one is server system, and these server system supports large volumes of data which frequently needed to access or to be modified. And also these server systems support request response operation. And next category is supercomputers, and these supercomputers are faster than mainframes, and these supercomputers are helping the calculating the large scale numerical calculations and algorithms in short span of time, and these are mainly used in our aircrafting design and testing and military applications and weather forecasting. So these are the supercomputers, and supercomputers are mainly used in where we require the large numerical calculation within span of time. Next we are going to discuss about what are the basic functional units of a computer, and this is a representation of our functional units in our computer. So there are mainly 5 functional units are there: input, output, memory, arithmetic logic unit and control unit. The arithmetic logic unit and control unit collectively called as a processor. Now we discuss about input unit. The computer accepts coded information through input units. Most well-known input device is the keyboard. Whenever a key is pressed by the user, the corresponding letter or digit is automatically translated into its corresponding binary code. The next one is output device. And what is the use of output device is the function of output device is used to send processed result to the outside world. The most familiar output unit is printer. And now we discuss about memory unit. Memory unit is used for to store the programs and data. To store our programs and data, we have 2 classes of storages are there. The first one is the primary storage, and primary storage is a fast memory. It is operating at electronic speed, and programs must be stored in memory while they are being executing. So in the memory we have large number of storage cells are there. So each storage cell is capable of storing 1 bit of information and processed in terms of words, and every word having its own memory location called address. The example for primary storage is RAM, and RAM is a temporary storage, and in this RAM we can store frequently used instructions, and the memory access time of our RAM is very less. So first of all, what is the memory access time? Is the time taken to access the information from the memory is called memory access time. And the second classification of our storage is secondary storage, and the secondary storage is very larger compared to our primary storage, and it is also very cheaper, and means in secondary storage we can store the large amount of information, and that is nothing but large amount of data or large number of programs are stored in our secondary storage. And in this secondary storage we can store infrequently used instructions. And this is about the classification of our primary storage and secondary storage. And now we discuss about another unit of our computer is arithmetic logic unit. So mainly in our programs we have number of arithmetic operations are there. So these arithmetic operations are executed in our ALU of the processor. So first of all, whatever the instruction is, they load the operand into the memory and bring them into the processor, perform operation in ALU and store the result back to memory or written in the processor. So now we discuss about control unit. Control unit. So in the name itself we have control. So all the operations in our computer, these are controlled by the control unit. The timing signals are generated by the control unit, and timing signals are the signals that determine when a given action is going to takes place. And now the final key points of our operations of our computer: accepts the information in the form of programs and data through an input unit and stored it is in the memory, and fetch the information stored in the memory under the program control into an ALU. So where the information is processed, output the processed information through an output unit. So control all activity inside in the machine through a control. And now we discuss about some basic operational concepts. And first of all we discuss about some suppose one instruction is there: add location a comma or not. So what is the meaning of this instruction is: add the operand at memory location A to the operand in a register or not in the processor, and the place the sum into again in the or not. So because of this addition operation, the contents of location A must be preserved. There is no change in the contents of location A, but the contents present in or not is replaced by the sum. So now how we can execute this instruction? We have some steps. So what is the first step is: the instruction is fetched from the memory into the processor. The operand at location A is fetched and added to the contents of or not, and the resulting sum is stored in our register. And now we discuss about what is the connection between memory and processor. So already we discussed what is a processor and what is a memory, and memory is nothing but it is used to store the programs and data, and processor. So processor is generally collectively whatever the ALU unit and control unit is there, that is collectively called as processor. Additional to that, we have number of registers are there in our processor. So n general purpose registers are there, R0 to Rn-1, and some special purpose registers are there. So that is memory address register and memory data register, and also we have program counter and instruction register. So these are the registers present in our processor. And now we discuss about what are the registers present in our processor. Instruction register. So this instruction register is used for to store the instruction. So which instruction is stored in our instruction register is which instruction currently being executed. And then we have the program counter, and program counter always use it for to store the address of the next instruction to be executed. And then we have general purpose registers are there, R0 to Rn-1. These registers are used for general purposes. And the next one is memory address register, and memory address register is used for to store the addresses. And memory data register, so these data register is used for to store the data. And now we discuss about what are the steps are there to execute our program. So generally if the programs are reside in the memory through the input devices, and program counter is set to the point to the first instruction, and now the contents of program counter are transferred to MAR. So now MAR generate one read signal and send to the memory, and the first instruction is read out and loaded into the MDR. So now the contents of MDR are transferred to instruction register and decode and execute our instruction. If there are any arithmetic operations in our instructions and those instructions are not transferred to IR register, and the contents of MDR register is transferred to ALU and perform arithmetic operation and store the result back in our memory or in our general purpose register. During the execution of our program, the program counter is incremented to the next instruction. Now the program counter consists of address of the next bus structures. So there are many ways to connect our different parts inside a computer together. So we have number of functional units. So how we can interconnect these devices means by using bus. So what is a bus? Means a group of lines that serve as a connecting path for several devices is called bus. So we have different buses are there. Address bus. So this is used for to carry the address. And then we have the data bus, and these data bus is used for to carry the data, and control bus is also there. So the control bus is used for to carry the control signals generated by the control unit. So this is about how we can interconnect the functional units by using single bus structure. So in the name itself we have only one bus is there. So by using this one bus we can transfer our information from different functional units. At a time only two functional units are communicating each other. So we have different devices are there. So these different devices are connected to our bus. So these different devices are having different transfer and operating speeds. If the speed of bus is bounded by the slowest device connected to it, so the efficiency will be very less. So how we can solve this problem means a common approach is there. By using buffer register we can solve our. Now we discuss the one important parameter of a computer is performance, and performance is the most important measure of a computer is how quickly it can execute the programs. And three factors are there to affect the performance of a system, and hardware design and instruction set and compile. And now we have an approach how we can improve the performance of a system. So performance of a system is depending upon the processor time. So processor time is depending upon the how the hardware is involved in the execution of the individual machine instructions. So generally the processor fetch the instructions from the main memory every time. So irrespective of that, so here in the itself in the processor we have some cache memory. So in that cache memory which instructions are frequently used, so those instructions are stored in our cache memory. So whenever we require that instruction we don't go to the main memory. So in the cache memory itself we have the number of instructions, so we can easily access the instruction from the cache memory. So because of that we can reduce the transferring between processor and main memory. So we can reduce our processor time, so we can improve the performance of a system. So this is one approach how we can improve the performance of a system. So in this approach we use cache memory. This is inbuilt in our processor. So now we discuss about basic performance equation, how we can calculate the processor time. So that is T is equals to N into S by R. So what is the T is the processor time. So time required to execute a program that have been prepared in high level language. So nothing but processor time. So N is number of actual machine instructions and S is number of basic steps needed to execute one machine instruction. Each step complete in one clock cycle. So R is nothing but clock rate, number of clock cycles per second. So up to now we discuss instructions are fetched by the processor and executing one by one. So irrespective of that, instructions are not necessarily executed one after another. So because to decrease the number of basic steps, so we have an approach that is called pipelining process. In the pipelining process, overlapping the execution of successive instructions. So by using pipelining process, so we can execute simultaneously number of instructions. So because of that, we can reduce our years, that is approaches, to less than. And now we discuss the one important parameter of a computer is So now we discuss another important parameter, so that is affect the performance of a system, that is called compiler. So generally what is the use of compiler is, it is used for translating high level language program into a sequence of machine instructions. So to reduce our n, we need suitable machine instruction set and a compiler that make use of it. So what is our goal is to reduce our n into s. Whenever we can reduce n into s, automatically the processor time is reducing, so we can improve the performance of a system. So now we discuss about another approach is there, how we can measure the performance of a system. So up to now we discuss how we can measure the performance of a system by using our processor time. So it is difficult to compute, so we have another approach is there to measure the performance of a system. So that is nothing but measure computer performance using benchmark programs. Here we have one system performance evaluation corporation select and publishes representative application programs for different applications, and these benchmark programs are compiled and run by the reference computer and under test computer, and this corporation committee give one rating to our computer. So here we have some formula how we can calculate SP's rating is running time on the reference computer to the running time on the computer under test. So by calculating this rating, we can say that the performance of a computer is good or not. So this is one approach how we can measure the performance of a system rather than the computing the processor time. So now we discuss about multiprocessor and multi-computers and multiprocessor computers. And generally up to now we discuss the computer having one processor, but here we discuss about multiprocessor. What is the use of multiprocessors is execute a number of different application tasks in parallel or execute subtasks of a single large task in parallel. So all the processor have access to all of the memory. So shared memory multiprocessor. So all the processor we can share the only one memory. So that is nothing but shared memory multiprocessor. And another one is multi computers are there. Each computer won't only have access its own memory. So but here exchange message via communication network means multi computers are sharing the information one computer to another computer via communication network, message passing multi computers. So this is about multi processor and multi computers.